this is an example of algebraic substitution. Algebraic substitution is one of the methods for or in solving integral. So actually we have 5 methods or techniques of integration, and one of that method is algebraic substitution. So by explaining this topic, we go directly to our example. We have integral of 2x plus 1 times the square root of x minus 3 dx. Now, in algebraic substitution, we usually use, from the word itself, substitution method. Okay, so we usually do the substitution, and then we have here the word algebraic. So usually we use variables to substitute. So say for example this one, the integral of 2x plus 1 square root of x minus 3 dx. Now in our former or in our basic integration, we cannot solve this problem. So we can use another techniques of integration, which is algebraic substitution. Now in an algebraic substitution, we use, let's say, any variable. So in this case, we will let's say z is equivalent to. Now in this problem, you have to select a portion which you think is more complicated for this particular problem. So for this case, we have, it seems that this square root of x minus 3 is makes this problem complicated. So we will take this x minus 3 as z. So we have the square root of x minus 3, and then after that we take the derivative of z. So dz, that is equivalent to, okay, we will make transposition. Okay, square root, that is z squared, is equivalent to x minus 3, and that z squared plus 3 is equal to x, and then take the derivative of this one, that is 2z dz, that is equivalent to dx. Derivative of 3 is 0. So derivative of x, that is dx, derivative of z squared equals 2z dz. Now after we have this z as our x, substitute all the values of x in terms of z. So we have 2 times x, our x here is z squared plus 3, z squared plus 3, and then plus 1, and then square root of x minus 3, that is equivalent to z, and then this dx, that is equivalent to 2z dz. This time substitute, multiply 2z squared. Okay, so we will continue here. That is equivalent to integral of 2z squared, 2 times 3, 6 plus 1, that is 7, and then multiplied by 2z squared dz. So that is equivalent to, multiplying this one, that is 2 times 2, that is 4z to the 4th, plus 2 times 7, that is 14, z squared dz. If we integrate this one, that is equivalent to 4 z to the 5th over 5 plus 14 z to the cube over 3 plus c. So this is u to the n. Let u equals z dz, du equals dz. So that is z to the 5th over 5. We have this one. Now after we find the value of z, the integration of this one using our substitution, this time we already integrate. Then this is not supposed to be our final answer. Instead of z, we will substitute the value of z as this one. So 4 over 5, z to the 5th, z is equivalent to x minus 3. Take note, this square root is 1/2. 1 half times 5, that is 5 over 2. And then plus 14 over 3. And then our z equals, again, x minus 3 times, 3 times the radical sign is 1 half, so 3 times 1 half, that is 3 over 2. Plus c. So this is algebraic substitution. So if you have noticed, in terms of x, our final is in terms of x. So if you have noticed, we have the substitution of variable z from this part. Okay, after that, we take the derivative and then substitute all the value of x. Instead of x, we have here z squared plus 3, and then instead of this one radical sign, radical of the square root of x minus 3, we have here z, and then instead of the x, we have 2z dz. So everything you have to substitute. In terms of x, substitute it to z. So that is one. And then after we integrate this one, we will go back to x. Okay? So instead of writing z, we will again substitute back from z to x. So this will be our final answer. We have here another example, square root of x over x plus 4 dx. If you look at this one, you cannot divide directly from square root of x to x plus 4 because the exponent here is 1 half and then this one is 1, so you cannot divide this one. Instead of dividing this one, we will be using algebraic substitution to solve this particular problem. Okay, so if you look at this one, what makes it complicated is the square root of x. Square root of x makes the problem complicated, so we assign variables of square root of x. So let's say equals the square root of x, so that z squared is equivalent to x. And then take the derivative of this one, you have 2z dz is equivalent to dx. This time substitute the value of x to z and then dx in terms of z. So we have instead of square root of x, substitute it to z divided by, instead of x, we have z squared plus 4, and then instead of dx, we have 2z dz. 2z dz. Okay. And then if we multiply this one, 2 times z, that is 2z squared dz all over z squared plus 4. This time, you can divide z squared over z squared plus 4 because the exponent here is 2 and then this one is also 2. So we have to divide this one. So we have 2z squared divided by z squared plus 4. So 2z squared divided by z squared equals 2. 2 times z squared, that is 2z squared, plus 2 times 4, that is 8. Subtracting this one, the result is negative 8. So we have, that is negative 8, 2 minus 8. So we have 2 minus 8 over z squared plus 4. Easy. So if you have here 2, this is the equivalent, and then this one is the remainder when you divide 2z squared over z squared plus 4. So if this is a remainder, when you write it here, so this is your remainder, this is negative, divided by your denominator, that is z squared plus 4. Now this one, okay, 2 integral of dz, I will distribute it first. 2 times dz, that is 2 dz, minus 8, I will write first 8, and then dz divided by z squared plus 4. This part is du, this is arctan. This formula is arctan, which is du over u squared plus a squared. So that is the case of, instead of a squared, that is 2 squared, which is equivalent to 4, and then this one is z squared. This is dz. Let u equals z, du equals dz. So this is arctan. This formula is an arctan. So that when we integrate, the integral of 2 dz equals to z minus 8, 1 over a. Our a is 2. That is 1 over 2, 1 over a arctan of u over a. U equals z over a, which is equivalent to 2 plus c. So our final answer is 2z. Okay. So by the way, this 2z, we have to convert back our z in terms of square root of x. So 2 square root of x, okay, instead of z, convert it to square root of x, minus 8 over 2, that is equivalent to 4, and then arctan of z is square root of x over 2 plus c. So this will be our final answer. Again, we substitute the value of x as z, square root of x as z. This is this square root of x makes this problem complicated. So let this square root of x equals z, and then take the derivative. And then after that, we substitute all x, square root of x as z, and then dx as this one. And then instead of x, we use z squared, and then integrate. After we integrate, we arrive to this value, and then after we have this integration, substitute back the value of z in terms of x. So we have this final answer. Another example is the square root of x minus 4 over the square root of x plus 2 dx. So what makes this problem complicated is the square root of x. Okay? Or you can divide this one first before we do the algebraic substitution. But in my case, I will go directly with algebraic substitution. So I identify square root of x as complicated for this makes complicated for this particular problem. So let's say equals the square root of x, and then z squared, this radical sign, the square root transferred to the other side, that becomes z squared, that is equivalent to x, and then take the derivative of this one, that is 2z dz is equivalent to dx. So this time substitute. So that is equivalent to, instead of having square root of x, we have here z minus 4 divided by z plus 2, and then dx is 2z dz. This is the equivalent of dx from this one. And then distribute first this one. So 2z squared, 2z times z equals 2z squared minus 8z dz all over z plus 2. So this time, if you have noticed, our numerator, that is z squared, and then the denominator is z, so we can divide this one. If we divide, that becomes 2z squared minus 8z divided by z plus 2. 2z squared divided by z, that is 2z. 2z times z, that is 2z squared. 2z times 2, that is 4z. And then subtracting this one, this is equivalent to 12z, negative 12z. And then this negative 12z, that is negative 8 minus 4, that is negative 12z. Negative 12z divided by z equals negative 12. Negative 12 times z, that is equivalent to negative 12 times z, that is negative 12z, minus 12 times 2, that is 24. When we subtract this one, we have here 24. So we will write here integral of 2z minus 12 plus 24 over z plus 2 dz. So if we integrate this one, that is equivalent to 2z squared over 2, so z squared, and then minus 12, integral of 12 dz, that is 12z, and then this one is ln of du over u. We will have du over u. Let u equals z plus 2, derivative of z plus 2 equals dz. So this is du over u. So that is equivalent to 24 ln of z plus 2 plus c. So our final answer here, instead of z squared, that is x, minus 12 over z equals square root of x, and then plus 24 ln of z equals square root of x plus 2 plus c. This is our final answer.